In galvanic cells, electricity is produced through a spontaneous redox reaction. These redox reactions can be represented as a pair of equations describing the reduction and oxidation of two chemical species at the electrodes. When connected by a wire, electrons will flow between the electrodes if there is a potential difference. These two electrodes are called the cathode and anode. A salt bridge helps to complete the circuit by acting as a counterbalance to balance the amount of cations and anions in the half cells. The electrode used to make the salt bridge must not interfere with the chemical reaction in the half cells, such as by forming an insoluble precipitate. At each half cell, a reaction occurs. The species that is reduced or oxidized depends on the relative reduction potential values. The more positive the value, the more likely reduction will occur. Consider an example of a redox reaction between copper and silver ions to produce copper 2+ ions and silver metal. The two half reactions are: since the silver half cell has a more positive reduction potential, silver plus ions will be reduced to silver metal, while copper will be oxidized to form copper 2+ ions. Let's look at the galvanic cell with copper and silver electrodes. The electrolytes will be copper nitrate and silver nitrate respectively. Hence, in this example, the copper metal will be the anode and the silver metal is the cathode. The two half cells are connected by a wire where electrons flow from the copper anode to the silver cathode, and the circuit is closed using a salt bridge containing a non-reactive electrolyte solution such as sodium nitrate, which transmits the current using sodium and nitrate moving ions. The salt bridge does not allow the mixing of the half cells. As electrons flow in the circuit, the nitrate ions in the salt bridge migrate to the anode. This keeps the anode electrically neutral by neutralizing the charge on copper 2+ ions produced during oxidation. Simultaneously, sodium ions in the salt bridge migrate to the cathode. These added cations replace the silver ions formed during the reduction of silver metal. This keeps the reduction half cell electrically neutral. After some time, silver deposits will be observed on the cathode, and the anode electrolyte solution becomes a more intense light blue because of blue copper 2+ ions.